Hi, welcome to this short course on higher order functions in Python. In this course, we'll go through what higher order functions are and give several interesting examples of this in Python. So first of all, just a quick definition. So what is a higher order function? Well, a higher order function is a specific function that either takes in other functions as arguments or returns a function as its result. When first encountered, this might not seem like that interesting, but this notion that we can pass in functions into other functions and return functions from other functions is essential in Python programming. In this course, we'll go through several interesting examples of this, including sorting, map and filter functions, and recursion. So, as prerequisites, I assume that you have installed Python 3 in some way. I'll be using Jupyter Notebooks, but you can use whatever you want. You should have a basic knowledge of variables, lists, and functions. So this course is great if you're still in the beginner level of Python, but we're gradually moving on towards the intermediate level. You do not need to know anything about higher order functions from before. Hi! I hope you're doing great. So in this video, we're going to make a few simple higher order functions. A big disclaimer, there's not going to be a single useful function in this video. In the next video, we're going to start discussing useful higher order functions. In this video, I really just want to focus on the simple concept of what a higher order function is. And this consists mainly of two things. First, passing in a function into another function, and secondly, returning a function from another function. So in this video, we'll just be making a few toy examples to get our intuition started about this concept and see how it works. So first of all, I just want to make two small utilities functions. And this is one function called add, which takes in two numbers, num1 and num2, and it returns what you think it does, namely just the sum. Secondly, I also just want to have a subtract function, which does exactly what you think it does. So it takes in two numbers and returns the first minus the second. So this is my two utilities functions. Now what I want to do is to start making functions that take these functions as arguments. So what I can do is to make a function called function +1. And this should take in a function, and it should also take in two numbers. So func here is supposed to represent a function, and what it will do is to return the function evaluated at num1 and num2, but as the name suggests, function +1 is to just add 1. So let's take this function for a test ride. I start by calling function +1, and I need to decide on a function here, so let me try the add function. Note here that I don't call the function add, I don't pass in arguments, I just pass in the whole function. I need to pass in two numbers, let's say 5 and 6. And then let me print this whole thing here. Then I return 12. So what happens is that the function I pass in, namely add, is evaluated on numbers 5 and 6. What it does is adding them, becoming 11, and then finally I add 1, and that becomes 12. So you can see here that I can simply just take in a function into another function in Python, and this is perfectly valid. So if I, instead of having add, do subtract, and run this, I will have 0, because I pass 5 and 6 into the subtract function here. This will become 5 minus 6, so that's -1, and I add 1, giving me 0. So passing one function into another one is perfectly valid in Python. And you can also see here that I return kind of a function, but not really. So this function here is evaluated, and then it returns a number, then that number is added to 1, and this is returned again. So strictly speaking here, I don't really return a function, I just return an expression with a function that is evaluated to a number. But you can also in Python return entire functions. So let me make a function I just called weird function. Should take in one function and a number, and it will simply check if the number is equal to 1. If that is the case, let's return the function. And if not, let's just return the number. So notice here that I return the function without evaluating anything. I simply return the whole function. So in this case, if I go and print weird function, and I pass in the add function and the number, let's say number 2, then I will simply get the number 2 because I am in this case. But if I pass in the number 1, what I get here is the function itself. And once I get the function itself, I can again evaluate this. So now this whole thing here essentially is just another way of writing the add function. So I can evaluate at, again, 5 and 6. Giving me 11. And of course, the same holds for the subtract function. like this. So now I get 5 minus 6, giving me minus 1. So this is an entirely useless functions, and I guess so is this. The important point here is that you can take functions and pass them into other functions, and you can also return functions so that after they've been returned, they can again be evaluated to give new values. One often use the expression that functions are first-class citizens, meaning that you can pass them into other functions and return them, so you can essentially treat functions just like any other value. So I encourage you to play around with this, pass functions into other functions, return functions, and really just realize that there is nothing special about being a function in Python. In the next video, we're going to step away from these toy examples and look at sorting. In sorting, passing in functions into another sorting function is essential to getting a good control of or sorting of elements. So thanks, and I'll see you again in the next video. Hi, and welcome to this quest on sorting in Python. In this video, we'll talk about the two main ways of sorting in Python and also how to pass in our own functions into the sorting functions to make them even better. So let us begin nice and easy by showing you the basic ways of sorting in Python. So here I have a list of numbers and I want to sort them. Then there are two options. First thing we can do is sort them into a new list. So here let's write sorted lists, and then I just use the built-in function sorted and pass in my list of numbers. So if I print out now the sorted list, I'll get numbers in sorted order. Note here that this gives me a new list, which is not the same as the original. So I still have access to the original one, and this has not been changed. So only the sorted list has been sorted. There's also a way of sorting in place in Python. What you do then is to call the method .sort on any list. So then I take my list of nums and I call the method sort, like this. Now my original list of numbers have been sorted, so I can try and print this out. And you can see that it has become sorted. A very common mistake for beginners is to think that, oh, this sort things, so then I should make some kind of sorted list and assign it to this. But this thing here actually returns none, so this is not possible. The .sort method sorts in place, so you should not assign this to a new list. Rather, you should just write list of nums.sort, and now the original one has been sorted. Which one of these you use depends on the context. If you want to modify the original list, then you would sort in place. If you want a new sorted list while keeping the original one, you would use this approach. I would say that in most occurrences you would use this approach so that you don't overwrite the original information you have. Okay, so far so good. Is there really anything more to say about sorting? And the answer is yes. So let's go down to a new cell, and I want to talk about passing in functions into sorted. So let's say that I have a list of purchase orders, maybe coming from an online store. Let me just paste this in here, and they're all on this form here. And let's say that I want to sort these orders. So with what we know, I'll just write, let's call this basic sorting. And let me here use the sorted function and pass in list of orders. And look at this and say, yeah, this is technically sorted, because what's happening here is that it compares these as strings. So if you compare, let's say, the two first numbers, both have the hashtag, so they're equal, both have the 1, so they're equal, but 7 comes before 9, so this is regarded as a smaller string. But if you intuitively gave someone this here and asked them to sort it, it would not probably look like this. Probably you would want this to be first, this to be second, this to be third, this to be fourth, and this to be fifth. This is not what's happening here, so this is probably not very useful in this context. So, what can we do to fix this? We can pass in functions into the sorted method to make custom sorting. So let's make a new list called sorted by length. And I'll use the sorted function and pass in my list of orders. But I want to change the way things are being sorted. So I can, in this function, pass in something called a key. And this key should be a function indicating how the sorting takes place. So let's first of all just try with the length function. And let me just print out the result. And also let me write sorted by length. Now we have this. kind of looks a bit better in the sense that the 7 here got in front, but here both of these strings here have length 3, so they don't really occur in the correct order. I think we would all of us say that 90 should be before 53 here in an intuitive approach, but it's at least somewhat better than this. Let's backtrack a bit and talk about what's happened. So in the sorted function, you can pass in an optional argument called a key, and I passed in the length function. What will happen is that then the length function is evaluated on each thing in the list. So length of this is 3, this is 2, this is 5, and so on. And then they're sorted according to that. So that's why the smallest one are here and the biggest one is here, but it's still not very satisfactory because this is not what I wanted. I wanted 19 before 53, and this is not sufficient because this just gives out the length. So the answer is pretty clear. I simply have to make my own function. Let's call it order sorting. It should take in one string. So let's try to think what I want to compare. I don't really care about this hashtag at all. I don't want to remove it, but I don't care about it when it comes to sorting. What I care about is the value of these numbers, namely the size of them. This number 7 is smaller than 19, 19 is smaller than 53, and so on. So what I want to return is each of these strings, but I don't care about the hashtag, so I'll slice it away. So this here makes sure that I take everything after the first character and only considers this thing, but I'm still working with strings and I want to compare numbers. So just convert this into an integer. And this is it. This function here takes in the hashtag 53 as a string and just returns 53 as a number. And now I can make my sorted, let's call it sorted by size. So far everything is the same, but here in the key I'll pass in my own function. Run it seemed to be working, so let's print out sorted by size. Here we have 7, 19, 53, and so on. Everything is in the correct order. So in the context of the higher order functions, we're passing one function, the order sorting, into another functions, the sorted function. And this is really, really useful. A lot of times you have data you want to sort, but you don't have it in precisely the format you want, so you need to make a short function specifying how you want it to be sorted. Before we end, I want to make a final example, and this is regarding Pokemon. So here I have a list of Pokemons, and notice that this is a list of dictionaries. So I have a list, and each item in the list is a dictionary. And each of these dictionaries has a name, which is, in this case, is Squirtle, Bulbasaur, or Charmander. They have a Pokédex index, which is a number, and they have a type. So, what do you think happens if I call sorted on list of Pokemon? The fact is that this will not only be a problem in terms of getting the wrong order, I will actually, if I try to do this, get a type error here. Hope you can read this, but it says that comparison is not supported between instances of dictionary and dictionary. Essentially, what this sorted tries to do is to take the items of the list, for instance this one, and compare them. But in general, there's no obvious way to compare two dictionaries saying that one is bigger than the other. However, if you take a look at this dictionary here, I think we can all get an intuitive sense of what I want to do. I want to order them by the only thing that makes sense, namely the Pokédex index. So I would want Bulbasaur first, and then Charmander, and then Squirtle. So how do I do this? I need to pass in a function as a key argument here, but there is no pre-made function for this. So I simply have to make my own function to do this. Let's call it sorted by Pokédex. This should take in one Pokemon. What should it return? It should return the thing I want to compare between them. So that is the Pokemon's Pokédex. Like this. And this is all there is to it. Let's just pass this to sorted by Pokédex and run it. So Jupyter Notebook automatically prints this for me. So here I have Bulbasaur first, and then Charmander, and then Squirtle. So this is in the correct order. A final thing you should know about the sorted method is that if you want to do it in reverse order, namely having 7 first, then 4th, then 1, there's a short way of doing this, and this is just by passing in a reverse argument. So this is by default set to false, but if I set the reverse to true, then I get the opposite order. You can of course do this by a function as well, but this is just a very convenient way of doing it. So I hope you can see that passing our own functions into other functions, this philosophy of higher order functions, can be really, really useful for getting what we want. This takes these kind of basic sorted functions, which works in some cases, in others not, to be working all the time as long as we can specify what we really need. Thanks, and I'll see you again soon. Hi. So in this video, we're going to talk about the map function in Python. So what does the map function in Python really do? So let me just paste in a short description. So the map function essentially takes in a list and a function and performs the function on each element in the list. So to wrap our heads around this, let's look at an example. So we had our list of numbers. This contained the elements 8, 15, 42, 23, 4, and 16. So say now that I want to create a new list containing each of these numbers squared. What I will then do is to first make a function. Let's call it square, takes in a number, and it returns the squared number. So what I want to do is to apply this function to each element in my list of numbers. Then I'll use the map function. In the first argument, I'll write my function. So this is the square function. Notice that I'm not calling the function on an argument, I'm just passing in the whole function. And the second argument is a list I want to apply the square function to. So this is the list of numbers. And now let me just print this and run the cell. What you can see here is that I've obtained a map object. If you're familiar with generators, then this is an example of a generator. But for our case, if you just want the list back, then what we can do is to wrap this into the list constructor. And here we have an array of the squared numbers. So 64 is the square root of 8, 225 is the square root of 15, and so on. So instead of printing this, I can simply also assign it to a new variable, new list, and that's about it. Before moving on to more examples, this is a great place to introduce lambda functions. So lambda functions are also what's called anonymous functions in other languages. And the motivation for lambda functions are this small annoying thing that I have to declare my own function here, give it a name and declare it here externally, even though I only need it at a single point here. It's not possible for me really to just paste this in here. This does not work, but what I can do is to make a function that is only supposed to be used once and doesn't really need a name. So for this, I can use a lambda function. So let me try to copy this, but instead of using the square function, here I'll make my own inline function with the lambda keyword. So you can see here that it recognized this as a Python keyword, and the syntax here is to send a number, colon, to the number squared. And if I now make this into a comment and just have this new list and print it out, you can see that it does exactly the same thing. So in this case, I don't really need to make an external function. You can do that if you want. This is a good idea if you want to use it multiple times. But if you only need to use a function once, then a lambda function is great. So again, the syntax is lambda, then the argument you take in, then a colon, and then the output. So this is a great way to make a short function that doesn't really require a name that we can just pass into another function. So to get a better handle of this, let's do a few more examples. So let's do an example where we have a few greetings. Let me just begin a new cell here. Here's a list of greetings. So it's hi there, hi-oh, good morning, and what's up. So what can I do about this? What I want to do is to make a new list where each entry in the list corresponds to the number of letters here in each of these messages. The first way I can do this is simply with a for loop. So this is just to illustrate that the map function is really just something you could achieve with a usual for loop as well. What you would then do is to make an empty array, let's call it length of greetings. Let's just initiate this to be an empty array. And then we do a basic for loop. So for each greeting in greetings, we take our length of greetings and we just append the length of the greeting. This is it. This is everything we need to do. And now we can print out the length of greetings and run this. And these are the lengths. So for instance, hi there has length 8, hi-oh has length 4, and so on. But instead of doing it the for loop way, we can do it with a map as well. So here, let's do it with the map. We need a function, and the function is simply the length function. This is already defined in Python, so everything is great. And greetings. Now this works. We should maybe also convert it into a list for simplicity. So let us again print the length of greetings. You can see now that this gives us exactly the same thing. This single line here is for me a lot more readable than first using one line just to initiate an empty list, and then 2 more lines essentially using a for loop to go through the list. Just a note, if you were to try this and you would write it with a lambda sending x to the length of x, just to clarify, this will also work, although it's not necessary since the length function is built into Python. So as a final topic, I want to show you that the map function can deal with more than one iterable. In our case, we're just working with lists, but you could also do other iterables, like for instance a tuple. So I've pre-written 2 lists here. One is a first name, and the second is the last name list. First names are Walter, Jesse, Skylar, and Gustavo, and the last names are White, Pinkman, White, and Fring. So I want to make a list called full names. I could do a double for loop to do this, but this is really annoying and a lot of code to do a very simple thing. So for this, I'll just use my map function. So to explain the syntax, I'll first pass in a function, then I'll pass in my first names, and then I'll pass in my last names. And for these two, this is not really a comment, this is precisely what I'm going to pass in. But for the function, I'll pass in a function that takes 2 arguments and returns essentially a combination of them. So again, I'll use a lambda, but in this time it takes in an x and a y. So first, x will be equal to Walter, and y will be equal to White, and I want them to be combined. So x and y should be sent to x plus, and then I need a space, plus y. So here the plus symbol is string concatenation. And really this is it. I should also convert this to a list at the end. Like this. Let me just run it. Looks fine. And if I print now the full names, you can see now that the full names have been put together. This is all I wanted to say about the map function in Python. It's a really convenient and easy thing to do. The map function is also present in a lot of other programming languages, so it's a good idea to get familiar with this. Thanks, and I'll see you again in the next video. Hi, I hope you're doing great. In this video I want to talk to you about the filter function in Python and how this is an amazing higher order function that can do a lot of different things. So a brief description of the filter function is that it takes in a list and another function and then filters out the elements in the list based on the function. So in essence it takes in a list of things and then it filters out some of them, leaving us only with a few of them left. And we can completely control which one we want to filter out. So for this, I think it's best to look at an example. So let's again consider our list of numbers. So let me just copy this. This is our list of numbers. What I want to do is just to filter out all the even numbers, leaving us only with the odd ones. One can do this, first of all, with a for loop. This is just to illustrate that the filter function is not really something scary. We can achieve this with a basic for loop as well, but you'll see that this is a bit cumbersome. So let me consider all the odd numbers versus an empty list. And then for each number in the list of numbers, then we check simply if the number is divisible by 2. So if it's not divisible by 2, that means it leaves a remainder of 1. Then we can take our odds list, and we can simply add to it the number. Otherwise, we do nothing. So now if I print the odds, then you can see here that the odd numbers here are 15 and 23. So we essentially filtered out all the even numbers. So this works fine, but it's a lot of lines of code just to do something very, very basic. So with the filter function, we can do this a lot quicker. So we make our odds, and now we do the filter function. So this should take in 2 arguments. The second argument should just be the list of numbers. The first argument should be a function specifying if we should drop a certain entry or keep it in the list. So we need a function, let's call it isOdd. And such a function needs to return a Boolean value. So this will simply return whether the number is divisible by 2. So if the number is an even number, then this thing here will be false. If it's an odd number, then it will be true. So if I now just put in isOdd as a function, then this will essentially take this function, apply it to each element in my list. Then I will have a list of booleans being true or false, and the filter function essentially just keeps the ones that have the value true. So if I print this out, then you can see that I've gotten a filter object. So this is a generator for those who know. And if you don't know, that's completely fine. We can always convert this into a list with a list constructor. And now this gives us exactly the same thing as the for loop approach. However, we can do this even shorter. Because we don't need to define an external function, we can just use a lambda function. So we can just use lambda, it sends a number to number modulo 2 is equal to 1. And now I can just delete this whole thing. And this single line here does the same as these 4 lines. And in my opinion, it's a lot more readable than doing the for loop approach. So the way I would read this is we take our list of numbers and we filter out based on this condition here. So to get more familiar with the filter function, let's do 2 more examples. So here, let's do an example with removing small words. So I have a list of greetings, and I want to just keep the ones that are small. I don't want a very long greeting, I want just small ones. So this is really easy to do with a filter. So I need a function, and I'll just specify a lambda function. Each of these messages I have here, let's call them x, should be kept if the length is less than 5. So this is the function, and the array is of course the greetings. And this is it. Again, now I'll get a filter object, so let me just pass this into a list constructor. If I print my short greetings, you can see that I have 1 too many parentheses here. This should be fine. Yeah. So now I get heyo and sup, because they are both of length less than 5. So for a final example, I just wanted to do an example with Pokemon again. So here I have a list of dictionaries, which I just called list of Pokemon, and each of these entries in the list is a dictionary with the name of a Pokemon, the Pokédex number, and the type of the Pokemon. Say now that I want to select all the water Pokemon in this list. Before we do this, if you take a look at this short video, then you can see that this is actually not too far-fetched. Here we're sorting out the Pokemons by specifying that I want all the water Pokemons back. So every time someone asks you, can you get me back like a sub-collection of what you have with a specified property, then you should immediately think of filtering out, and using the filter function could be a good approach. So in our case, we want the water Pokemon. This should be filter, and since I already know that I should have a list constructor, let's just have it from the beginning. So inside the filter function, I need as a second argument my lists of Pokemon. Hope I spelled that correctly. Yeah. And then I need a function. I'll do an anonymous function or a lambda function here. And what I want to do is to return if the Pokemon's type. So then I'm going into each of these Pokemons. I'm looking into the type, and I want to check if this is water. If it is, I want to keep it. If not, I don't want to keep it. So by running it, it seems fine. And if I now print the water Pokemon, then I get back just Squirtle because that has the type of water. The other ones don't have this property, so they're simply filtered out. This is really what I wanted to say about the filter function. Again, notice that this is really within this higher order functions approach, and passing one function, namely this lambda function, into another one, namely the filter function. Thanks, and I hope to see you soon. Hi guys, and welcome back. In this video I want to talk about list comprehensions and how they are an alternative in Python to using map and filter. This video will not include any new higher order functions, it simply exists to give you an alternative to using the map function and the filter function. So let's start with the map function. We saw previously that if we had this list of numbers list here, then we could square every number in the list by using the map function. Let me use the map function, make a specialized lambda function sending x to x squared, and I'll pass in my list of nums. And again, as usual, I then need to pass it into the list constructor, and here we have it. So this is just repetition, but in Python there is another way of doing this called list comprehensions. Let me call the variable squares2, and to write the list comprehension, what you do is to make the list brackets here, and then you say the numbers squared for each number in the list. So you should read this as we take the number squared for every number in this list. So if I print this out, then I get precisely the same. These two things are mostly equivalent in Python, and it really depends on what you want. Many people who do write Python actually prefer this one because it's more readable. Here you can read, we make the squares by taking each number squared for each number in the list, so it's very readable. While here, you take a map and mapping the list of numbers by this function, so you really have to read it like map this thing with this function, so it's a bit more nonlinear in the reading, but they do essentially the same thing. So, let's talk about the filter function. So what we did with the filter function, among other things, is to filter out the odd numbers. Let's just recall this by making a variable called odds1, use the filter function, make a lambda function sending x to x divided by 2 is not equal to 0. So we pick out the elements whose remainder by 2 is not 0 but 1. And we apply this again to the list of nums. Then we'll get the filter object, so again we pass this into the list constructor, and now we have all the odd numbers. In this case it's 15 and 23. Again, this is just repetition, but this can also be done with list comprehensions. Write the same square brackets, and now we want all the numbers for each number in the list. So we don't want to transform the numbers, we just want to pick them. But we don't want to pick all of them, so this we can specify here by saying if the number divisible by 2 is not equal to 0. And again, let's print this out. And I get an error just because I have spelled this wrong. So it should be nums. And here you can see now that this is exactly the same. Again, the same reasoning applies here. You can do it with either the filter function or list comprehension. List comprehension is very specific to Python, while the filter function is again present in most functional programming languages. In the beginning, it can be a good idea to try to write it both as a list comprehension and as a map or filter function, just to get comfortable with both. Ultimately, it doesn't really matter that much which one you choose, but it's good to be aware of both options. Thanks, and I'll see you again in the next video, where we will talk about recursion and how this is an example of higher order functions. Hi, I hope you're doing well. So in this video, I want to give you a very brief introduction to recursion. The definition of recursion is, at least simply put, that it's a function that calls itself one or more times. If you're not used to this, then this can seem rather abstract and also pointless. Why should a function call itself? The example we're looking at is the factorial function. So, for those who don't know, we have the factorial function in mathematics, and this is defined, at least iteratively, as n factorial is the same as 1 times 2 times 3 and so on, all the way up to n minus 1 and then n. So this is a number that's used in combinatorics, and it's actually not that hard to compute. So for instance, if you have 3 factorial, this is equal to 1 times 2 times, and just multiply all the numbers all the way up to 3. So 1 times 2 times 3, this is equal to 6. It's easy to compute. We can now write a function that takes in a number and gives us that factorial number. And I will call this factorial iterative simply because this will be an iterative solution, meaning that we iterate through the numbers all the way up to the number we're given and then make this factorial. So this is a very brute force way of doing it. We can just take factorial, so far set it equal to 1, and then for each number in the range from 1 to num plus 1. I do num plus 1 here simply because in the range function the last number is not included, so I need to do num plus 1. Then we take the factorial number and then set it equal to itself times this number here. Then once this is done, we can simply return the factorial. So this here, just to write it out, this is the same as writing this is equal to factorial times this. So this is maybe more readable. Now, let's print out the factorial iterative of, for instance, 3. Run this, we get 6. Run it with 4, and we get 24 because 1 times 2 times 3 times 4 is 24. So far, this has nothing to do with recursion. This is an iterative solution. But this problem can also be tackled in a different way by using what's called recursion, making a function that calls itself. So before we start writing, let me remark something. So n squared can also be defined recursively as 1 squared is just 1, and n squared is equal to n times n minus 1 squared. So what does this mean? This means that if we're given 3, so let's do the same example, 3 factorial, then let's check. It's not 1 factorial, so then we're in this case, and 3 factorial is 3 times 2 factorial. So this here is 3 times 2 factorial, and 2 factorial, again, now we can apply the same rule to this. It's not this case, so it's 2 times 1 factorial. And now we're in this case, because 1 factorial is equal to 1. So this is just 1 again, and this is 6. This is just a different way of computing it, but this different viewpoint gives me a different approach. Now I can essentially make a function that calls itself. I take in a number, but I want to call it again with one lower value. So let's do this. So this is the recursive version. Takes in a number. So first we should check if the number is equal to 1. Then we should just return 1. Otherwise, we want to return the number times, and I'm just using this formula, the number times n minus 1 factorial. So this is again calling the same function with one number lower. Notice that this is a higher order function because one function, namely this, is being returned from another function. And with this, let's just print factorial recursive of 3. So I get a name error here, it's just because I spelled it incorrectly over here. So let me just copy this. And then we can again see that we get 6 for 3 factorial and 24 for 4 factorial. So these both solve the same problem. So let's just take the 3 case and do a quick walkthrough. I pass in the number 3. This is passed in here as number. It's checked, is it equal to 1? No, it's not. So we're in this case, we return 3 times the factorial of 2. Notice this is exactly the same that happens here in the comment. And then the function is again called with the number 2. Is it equal to 1? It's checked. No, it's not. So we're then in this case, it returns 2 times the factorial of 1. Then we're into the 1 case. It's checked. Is num equals to 1? Yeah, that's true. So this innermost function returns 1. This gets passed up and gets multiplied by 2, which again gets passed up and multiplied by 3. So we get 3 times 2 times 1, which is equal to 6. So recursion is a way to solve a big class of problems simply by returning the function again inside the function body. Recursion can be used as a problem-solving approach that can be compared to the iterative solution. And in my opinion, actually, this here is, once you get used to thinking about recursion, this is for me a lot easier to read. Except for this special case here, it's really just a one-line thing here. While here we first need to initiate a factorial and then do a for loop and so on. So for me this is a bit easier to read, but of course in such a simple example as the factorial, both approaches are perfectly fine. So the philosophy of this short course is that functions that either take in another function or return another function are very interesting. So we had examples of functions taking in other functions like sorting with keys and the map and the filter function. And here we have an example of a function that returns another function. This is very common in strategies where you use recursion to solve a problem. If you're interested in recursion and want to learn more, then I suggest that you read up on Fibonacci numbers. This is also a construct from mathematics. It's a great example of recursion. So this marks the end of this short course. What I suggest you do is to make your own example of a higher order function. It can be based on map, filter, sorting, recursion, or something completely different. Thanks, and I hope to see you soon.